Today we will going to solve exercise 14.2, all the B part question. Come to the first question. In the first question, we have saying that the blood groups of 30 students of 8 are recorded as follow. You can say their blood groups are written here, A, B, O, and there so on. 30 students blood group. What you have to do, you have to represent this data in the form of frequency distribution table. Which, okay, this is the first part. Then I will come to the next part, which is the most common and which is the rarest blood group among these students. Okay, for this one, for this data frequency distribution table, we already discussed in the Zoom class. Okay, we already discussed what is frequency distribution table. Later in the solution we can discuss again. Come to the solution. This is actually a frequency distribution table. So blood groups we wrote A, B, AB and O. They're the four blood groups we can see. Okay, and tally mark. What is tally mark? We'll discuss what is tally mark. And number of student. Number of student is actually frequency. Here blood groups is saying A. So we have to count how many A blood group students are there. You can see A, 1. Whenever you are saying you are finding one value here, you have to write like this. You have to do like this. Again for second one, you can see in the first row this is second one, again one here. Okay, similarly 1, 2, 3, 4. Whenever the fifth one, for fifth one you have to strike like this. Okay, then other 1, 2, 3, 4. Okay, so this means 5. Okay, it make our calculation easy. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9 A are there. Okay, so for first 5 we wrote like this, then 1, 2, 3, 4, so total 9. Similarly for B, find out 1, so we'll write here one line like this. Another B, first line, so here also we will write like another strike out in tally mark like this. Will for each B we will write like this. So how many B? Let's calculate. 1, 2, 3, 4, 5, 6. So look, here we found the 6C. Similarly AB also, there are 3 AB. O, you can find O. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 you can see. Okay, for each value you can find from the data, you have to strike 1, 2, 3, 4 and then 5. Strike out 1, 2, 3, 4, strike out 5. Okay, so similarly, so you got 12O. Then we have to write total. For tally mark we don't have to write anything in total column, total row, and here we have to write 30. So ultimately this is actually our frequency distribution table. Okay, now our second question was, which is the most common and which is the rarest blood group among the students? So how to find the most common? You can see how many students got O group. 12 students. So that means 12 maximum students have O blood group. So most common blood group is O blood group, as 12 students have it. And which will be the rarest? You can see AB, because only 3 students have AB blood group. So rarest blood group is AB blood group, because only 3 students have it. Next, question number 2. Question number 2 is saying the distance of 40 engineers from their residence to their workplace were found as follows. So these data are given, that is the 40 engineers, their distance between their workplace and the residence, that is given here. So what we have to do, we have to construct frequency distribution table with class size is 5. Okay, we already discussed what is class size mean. Still we will discuss again. Of data given above, taking first class interval is 0 to 5. Then we will come to the second question. First come to the first part. First part, we have to make a frequency distribution table. Now this 0 to 5, okay, this is called class interval. Okay, and what is class size? In class interval, this left side one is called lower class limit and the right side one called is upper class limit. Okay, so difference between them is called class size. You can see what is 0, 5 minus 0 is 5, 10 minus 5 is 5, Even 30 minus 25 is 5, right? So class size is constant for all class interval. Now come to the question. First class interval is 0 to 5. Let me see how many for this. Look, this is called continuous frequency distribution. We already discussed, right? 0 to 5, again second line 5 to 10. The upper class limit of first class interval is equal to the lower class limit of the second interval. Okay, so this called continuous. For the continuous frequency distribution, what we have to do, in the first interval we can take only 0 to, in first class interval we can only take 0 to 4. Okay, 5 we can't include. For all group continuous group frequency data, we will not include the upper class limit. So here we'll check how many data are there whose value is 0 to 4. Let's check. In first line you can see 3. Okay, so for 3 we are writing here 1 this line. This is not 1, okay, this is a line. Then on the first column there is no second column, last line is 2. So for 2 another 1. Then second, third column we got 3. So for 3 another 1. Okay. Then on the third column last one is 3. So for this 3 another 1. On the last column 2 is there. For 2 fifth value, so we will strike out. And you can see there is no value which is less than 5. So we got 0 to 5, there is 5 value. Now we have to take 5 to 10. 5 to 10 means we can include the value 5 to 9, not 10. We'll count the value 5, 1, 5 is there. So for this 5, I'm striking 1. Another 7 is between 5 to 10, which is less than 10. So for 7 we are striking 1 line. Then second line no one. Third line 7 and 9, and again 7, 8. 1, 2, 3, 4. For 4 we'll write 1, 2, and this is 5th, and this will be 6th. You can count 1, again 2, 3, 4, 5. So there are another 5. So total 11. You can count by yourself also. Okay. Similarly, next 10 to 15. 10 to 15 will be, actually we have to take 10 to 14, right? So let's calculate 10 to 14. We can include 10, 1, 2, 3, 4, 5, 6, 7. Not 7. This is not in between less than 15. So 6, 7, 8. We can't include the 15. 9, 10. Then 11. So you can see 11 data. Okay. Similarly, 20 to 20, 15 to 20. 15 to 20. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see, so 9 data. Similarly, 25 to 30, 1 data. 25 to 30, 1 data. 20 to 25, 1 data. 25 to 30 is also 1 data. And 30 to 35, 2 data. You can find from this one. The total is 40. Next part of this question. What main feature do you observe from the tabular representation? So from the tabular representation, I want to see one thing. Look, maximum engineers are from this category. Which category? Whose distance is 0 to 5, 5 to 10, 10 to 15, and 15 to 20. Up to this category, maximum engineer. Only you can see 1, 1, 2. This category only 4 engineer. So what observation 1 we can write? Most of engineers, 36 out of 40. You can calculate. 5 plus 11, 16. 16 plus 11 is 27. 20 plus 7 plus 9 is 36. So 36 out of 40 engineers residence is between 0 to 20 kilometer. Okay, you can see from here 0 to 20, this category 0 to 20 kilometer. Okay, so comparatively they are very nearer to others. Only few 4 out of 40 engineers have residence is 20 to 35. Okay, so 20 to 35 only 4. 1 plus 1 plus 2 is 4. Now one question I did not told, why I took up to 35 here. because the data here given, all data are less than 35. Okay, the highest maximum data is 32. Okay, so we took 32, 35 last one. Question number 3. In question number 3 is saying the relative humidity in percentage of certain city of for a month of 30 days was as follow. So this is the relative humidity. All the values are given. How many days? 30 days value are given. Okay. First question is construct a group frequency distribution with classes 84 to 86, 86 to 88, etc. Let's come to the solution. So we make a table. Relative humidity will be our first column, tally mark as usual our second column, and number of days. You can write frequency also in the number of days. Okay, so this is our group frequency data. So as given in the question, we have to take 84 to 86, 86 to 88, 88 to 90, 90 to 92, like this up to 100. So here class size is, what is the class size? 86 minus 84, 2. Okay, and class interval are 84 to 86, like that. So let's check between 84 to 86 how many data. That means we can take less than 86 value. Okay, we can take 85.9, 85.8, but we can't take 86. So we have to take between 84 to 86. Let's check. On the first row there is no number 84 to 86. Second row, third row, you can see one value is there, 84.9. So we mark one line here. Then check on fourth row, fifth row, no 84 to between 86, no data. Next is 86 to 88. Let's check on first line, 86 to 88, no data, no data. 86.5 we got here, so we'll write 1. So first line, this is 1. Second column, second interval also 1. Next data is 88 to 89. So 88 to 89 on first row, you can see 89.9. Sorry, 89.2. So this data is between 88 to 90. So we are marking one line here. Next line, no. Next line, no. Next line, also no. Next line, also no. Next line, next row, next row, next row. Last row we got 89, right? So 89 also, 88 to 90, between the 89 to 90. So another strike. So that is 2 data. Next is 90 to 92. 90 to 92. First row, no. Second row, no. Third row, no. Fourth row, we have 2 data. 90.3 and 90.2, both are between 90 to 92. So 2 strike we can writing. Okay, let's check the other row. This row also no. This row, this row, this row. There is no other. So this data is 2. Next, 90 to 94. On first row there is nothing. On second row, 92.3, 92.1. So for these two, you are writing 2 strike. On the third, no. On the fourth, yes. On the fourth also 1 data is the 93.5. For the 93.5, I am striking another one. Okay. On the fifth row, another is 92.7. For 92.7, I am writing another strike. On the fifth row, there is nothing. On the sixth row, we have 92.9. For 92.9, we are striking out. So 5 data we already got. On the second last row, we got 93.3, which is between 92 to 94. So for this one, I am striking here another one. And here we got the second last row. We got 92.1. So for this one I am striking again. So we got 7 data. Similarly, between 94 to 96, 94 to 96, 94 to 96, this row no. Yeah, this row 93.5, 1 data. 95.7, another data. 95.3, 95.1, another data. 4 data we got. Then 94.5, this is another 1 data. So 5th data we got. 95.2, 6th data. Okay, so we already got how many data? 6 data. 94 point, so for 94 point, 1 2 3 4 5 6. 6 data we got. You can find from here. 96 to 98. So 96.1 2 3 4 5 6 7. 7 data we got. So between 96 to 98, 7 data we got. So we wrote here 98 to 100. For 98 to 100, 1 2 3 and 4. 4 data. You can see 4 data we got. Okay. So total, if you got the total, we got 30 data, and this is our frequency distribution table. You have to count from the this data carefully. Okay. Now second question, here two question asks, which month or season do you think this data is about? If you consider the data, you can see maximum value are from this category. Okay, that means humidity level is 90 to 94, 94 to 96, 96 to 98, 98 to 100. That means humidity is very high. Which season humidity is very high? That must be a rainy season. You can see as the table show, most days, 24 days, you can count 7 plus 6, 13 plus 7, 20, 24. 24 days are with high humidity between 90 to 100. So therefore it is a rainy season. Now third question asks, what is the range of the data? Range means we know, range means the maximum value minus the minimum value. What is the maximum value? 99.2. You can see here 99.2. And what is the minimum value? 84.9. So 99.2 minus 84.9, that is equal to 14.3. Question number 4. In question number 4 is saying the height of 50 students measured to the nearest centimeter have been found. So this is the data of given of 50 students, their height are given. Okay, 1 2 3 4 5 6 7 8 9 10 column are there, so each column 5 data. What first question asks, represent the data by group frequency distribution table, taking class interval as 160 to 165, 165 to 170, like this. So we have to make a group frequency data, group frequency table, distribution table. Let's come to the solution. Here we wrote first column is height in centimeter, tally marks as usual common, number of student, that is actually frequency. So there is a little bit mistakes I did. This interval will be, class interval will be 150 to 155, because here I found that 150 is the smallest one. Okay, so we have to start from 150. So 150 to 155, 155 to 160, I think it is visible. 160 to 165, 165 to 170, 170 to 175. Okay, so now 150 to 155, let me check. So 150 to 155, this class interval we can take only 150 to 154. Okay, so let's check the first column. First column 153, 154, then 1 2 3 4 5 6 7 8 9 10 11 12. So you got 12 data. Okay, so for that tally mark you can do like this with pencil. Okay, or otherwise cross something, whatever you want you can do. So 150 to 155, there are 12 data. So tally mark will be 1 2 3 4 5 strike out, 1 2 3 4 5 strike out, and 1 2. So there are 12 data. Similarly 150 to 160, let me check. 155 to 160. So 155 to first column, no, this is these 2 3 4 5 6 7 8 9. So 9 data we got 9. So 1 2 3 4 5 strikeout, 1 2 3 4, total 9 data. Similarly 162 165, let me check 162 165. So you can take only 162 164. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 actually. 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Okay, so we got 14 data. 1 2 3 4 5 strikeout, 1 2 3 4 5 strikeout, 1 2 3 4 14 data. Similarly 165 to 170, that is less than 170 actually, so we have to take 165 to 169, that will be 10 data. And 170 to 175 we can find from here, do by yourself this part. 165 to how many data, it will be 10 and 5. So last column will be total, this tally marks column will not write anything, and number of students will be 50. Okay, now question number 2, second part. What can you conclude about the height from the table? From this height, we got the table. What we can conclude? We can conclude, look, maximum students are from this category, 12 9 14. Okay, there are 50 students, so only less students in this category. So what we can conclude, number of students whose height less than 165, this student have height less than 165, right? 150 to 165 is 12 plus 9 plus 14, 35 out of 25, 35 out of 50 is 70%. So 70% of the students are shorter than 165. Okay, next question number 5. Question number 5 is saying a study was conducted to find out the concentration of sulfur dioxide in the air in parts per million of a certain city. The data obtained for 30 days as follows. So you can see there are data 1 2 3 4 5 6 column are there, 30 days. We have to, first part is make group frequency distribution table for this data, which class interval is 0 to 0.4, 0.04, 0.04 to 0.08, and like that. So we already made this table. You can see parts per million is, we made the table like this, 0.00 to 0.04, 0.04 to 0.08, like that. We found that 0.22 is the highest. So like that 0.20 and 0.20 to 0.24 will be our last class interval. Now 0.0 to 0.04 rule are same, we have to take less than 0.04. Let me check how many data. 1 2 3 4, yeah, 4 data. So 1 2 3 4 for line and 4. Next 0.04 to 0.08, 0.04 to 0.08, that means we can take less than 0.8. So we have to take 0. Up to 0.07 or like that. So 0. For this 1 2 3 4 5 6 So again I'm calculating 1 2 3 4 5 6 7 8 9 data we got. So 1 2 3 4 5 cross 1 2 3 4 9. Next 0.08 to 0.11. okay, 0.08. So 1 2 3 4 5 6 7 8 9 data. So let's see, we have 9 data. So 1 2 3 4 5 cross out, 1 2 3 4 9 data we got. Now 0.12 to 0.16, 0.12 to 0.16. So we can take up to 0.15, 0.12 this data, 1 2, only 2 data we got. Look, we have 2 data. So similarly these two column you can do by yourself. 0.16 to 0.20 you can find out from there. Okay, and you can see this one, how this will be the data. 4 data between 0.16 and 0.20, and 0.20 to 0.24 there are 2 data. Okay, now our first part is completed, that is making the table. Our second part is for how many days was the concentration of sulfur dioxide more than 0.11 parts per million. How many days the concentration was 0.1 or greater. So we can see these are the day. This is 0.12 to 0.16, 0.16 to 0.20 and up to 0.24. So this part is greater than 0.11. So these are the day 2, 4 and 2, okay, where concentration was more than 0.11. So the concentration of sulfur dioxide more than 0.11 ppm, that is parts per million. 2 plus 4 plus 2, that is 8 days. Next question number 6. 3 coins were tossed 30 times simultaneously. Okay, simultaneously means back to back. Each time the number of heads occurring was noted as follows. So number of head occurring first time, there is 0, second time like that, 30 times they did, and we noted the heads, number of heads each time. Okay, now we have to prepare the frequency distribution table. Here we will not do the group frequency distribution, we will do ungroup frequency distribution, because the value is 0, 1, 2 and 3. So we have to do ungroup frequency distribution. Like that you can see there is table already there. So number of head is first column, tally mark as usual, frequency as usual, last column. So 0, 1, 2, 3, this is ungroup. Look, there is no class interval, there is only 0, 1, 2, 3. So we have to count how many 0 are there. Let me check. 1, 2, 3, 4, 5, 6 0. You can see 6 0. So 1, 2, 3, 4, 5 cross out, 6. So 6 here. Let me see how many 1 are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 1. You can see 10, 1. 1, 2, 3, 4, 5 strike out. 1, 2, 3, 4, 5 strike out. So there is 10. For 2 and 3 you can find by yourself. Okay, let me know. For 2 you have to find from the data, and 3 also you have to find. This is already given. 9, 2 and 3, 5. So total 30. So this is our frequency. Here only frequency table asks. This is our frequency table. Now question number 7 asks the value of pi up to 50 decimal places given below. So this is the value of pi. Okay, that is given 3.1415926535, like that, many digits. There are 50 digit decimal is given. What we have to do, we have to make a frequency distribution table of digits from 0 to 9 after the decimal. So after the decimal we will not consider the 3. After decimal point there are 50 digits. Okay, so we have to count how many 0, how many 9, like that. So we have to, this is also ungroup frequency distribution table. So 0 digits is the first column, tally mark, frequency. 0, 1, 2, 3, 4, 5 up to 9. Let me see how many 0 are there. 0, this is 1 0, this is another 0. So 2 0 we have. There is 2 0. How many 1? 1, 2, 3, 4, 5. 5 1 are there. So we wrote 5. Next 2, 3, 4, 5 up to 9 you have to do by yourself and check is it correct or not. If it is wrong, let me know. So this is our distribution 3. You can see there we got 8 3, 4 4, 5 5. I guess you understand. You have to count how many 5, how many 6 are there, and you have to write in this table. Total is 50. Come to the second part of this problem. Second part is saying what are the most and least frequent number. In this decimal, what are the most occurred number and what is the least occurred number. So least occurred number, obviously whose frequency is less, that is 0. Least occurred number, occurring digit is 0, twice. What is the maximum occurring digit? Obviously whose frequency is bigger, 8, here also 8, so that number is 9 and 3. Okay, the digit is 3 and 9. So we have to write 3 and 9, both are 8 times. 8. Question number 8 is saying 30 children were asked about the number of hours they watched TV programs in the previous week. The result is found in a given there in this table. So this is the table where the given the how many times or how many hour children watch TV. First question is saying make a group frequency distribution table for this data taking class width 5. Okay, class width means upper class bound limit minus lower class limit, the difference must be 5, and one of the class interval must be 5 to 10. So let me do the frequency distribution table. So this is, you can see this will be a group frequency data. So number of hours TV, okay, that is 0 to 5, 5 to 10, 10 to 15, 15 to 20, and telemark are like this. So 0 to 5, let me see how many data are between 0 to 5. 0 to 5 mean we can take up to 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 data. So 0 to 5 we got 10 data. So 1, 2, 3, 4 strike out for 5, 1, 2, 3, 4 strike out 5, 10 data. Let's see 5 to 10. You can see 5 to 10 already there. Okay, and in this question it is asked that one class interval must be 5 to 10. Let me see how many 5 to 10. So we can't include 10. We can include this 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 data we got. So 1, 2, 3, 4 strike out, 1, 2, 3, 4 strike out, 1, 2, 3. 13 data. For 10 to 15 and 15 to 20 you must do by yourself. Let's see it is 5 or 2 or not. Okay, the total, I hope you understood that 10 to 15 there are 5 data and 15 to 20 only 2 data. So total is 30. Now second part of this question asks how many children watch television for 15 or more hours. From the table we have to understand 0 to 5, 10 children, 5 to 10, 13 children, 10 to 15, 5 children, and 15 to 20, more than 50 there is 2 children. So there are children who watch television more than 15 or more hour in a week. 15 or more hour in a week is equal to 2. Okay, last question of this exercise 14.2, that is a company manufacture car batteries for a particular type. The lives in years of 40 such batteries were recorded as follow. This is the life of battery they are given. Okay, so you can see 1, 2, 3, 4, 5, 6, 7, 8 column are there. What we have to do, we have to construct group frequency distribution table for this data using class interval of size 0.5 and starting from 2 to 2.5. Okay, so we started with 2 to 2.5. Okay, like that 2.5 to 3.0, because it's saying that class interval size must be 0.5. So the difference between them must be 0.5. Here also 3.0 to 3.5, like that 4.5 to 5.0. Why? Because we found some data that is 4.5, 4.6. Okay, more than 5 we can't, here no data is there that is more than 5. So we'll take the last interval, that is 4.5 to 50, 5.0, sorry. So let me check how many data are there, 2.0 to 2.5. So for 2.5 we can take up to 2.4. So let me check 2.0 to 2.4. 1, 2, only 2 data. Yeah, only 2 data we got. 2.0 to 2.2, only 2 data we got. Similarly 2.5 to 3.0 we will get 6 data. 3.0 to 3.5, let me check how many data are there. So we can take up to 3.4. 3.4, 3.3 to 3.4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there are 14 data between 3 to 3.5. So 1, 2, 3, 4 strikeout, 1, 2, 3, 4 strikeout, 1, 2, 3, 4. So 14 data are there between there 3 and 3.5. Then 3.5 to 4.0. Let's check. We can take up to 3.9. So 3.5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 11 here. So there are 11 data. 3.5 to 4.0, there are 11 data. Okay. Similarly, 4.0 to 4.5 you can do by yourself in the home. It would be 4 data, and 4.5 to 5.0 will be 3 data. So ultimately last line will be total is 40. So this question was asked to construct only group frequency data table. So this is our group frequency distribution table.